I need a meaningful interpretation of what the limit of an nth term of a sequence is being equal to L as n increase up now. I don't know if I said that very well. Given a sequence as such, I need a rigorous definition describing what this really means. Now, I think intuitively, it's pretty darn clear after all. As lowercase n increases, if this really is true, then I think what's really happening is that the terms, which are represented by these dots, are simply getting closer and closer to the line y equals L. But that's an intuitive notion of looking at it, so let me make it a bit more rigorous. Notice how if I choose my lowercase n to be bigger than, say, this value then right here, I'll call it uppercase n. Is it not true that for all values of lowercase n, they're bigger than big N? It is the case that all these dots are within my horizontal band as in red. Okay, looks like I made a mistake. Looks like that one isn't. But if this really is a true statement, it just simply means eventually there'll be a large value for n for which all lowercase n's, bigger than it, will give me the nth value within epsilon units of L. So very analogous to your continuous definition of infinite limits with your previous course. Let me formalize this. Excuse me. My apologies. So let me formalize this. From here on out, this means the following. For all epsilon greater than 0, there exists an uppercase n such that, now I have two different ways of saying this. First way around, such that in absolute values, the deviation between my nth term and my limiting value is no more than epsilon units whenever I choose lowercase n sufficiently large. Now, sometimes I feel a bit awkward with the word whenever. I might rephrase this in terms of if-then conditional statement. In other words, if n is chosen sufficiently large, then if this is true, it necessarily has to be the case that the absolute deviation between these two beasts is indeed strictly less than epsilon. Just a different way of saying the same thing up here with upward whenever.